The topic for week 4 is multiple integrals. So again, I'm going to sort of follow the same design I used in week 2. I'll start off just by defining what a multiple integral is, and because I want to be able to visualize this, I'm just going to talk about double integrals. The second section is something called Fubini's theorem, and this is sort of like the fundamental theorem of calculus gave us a way to evaluate an integral, a single variable integral. Fubini's theorem allows us to use something called an iterated integral to evaluate a double integral or a multiple integral. In section 3, I'll talk about something called the change of variables for double integrals. So this is if I want to substitute one of my variables with an expression, how I can modify my integral so that it still evaluates to the same number. In section 4, I'll just go through an extended example of that. And in section 5, I'll show that there's a certain class of double integrals that are called separable, where without actually doing any integration, you can separate them into two single variable integrals, and that'll make the calculation a little bit easier. In section 6, I'll talk about one particular type of change of variables, which is re-expressing the problem in polar coordinates. So if the original problem was expressed in terms of x and y, that would describe a point in the plane. Polar coordinates allows me to describe a point in the plane using r and theta. So r is a distance from the origin, and theta is an angle from the positive x-axis. In section 7, I'll do something called a culturally important integral. So if you've looked at the standard normal density, you'll notice there's this 1 over the square root of 2 pi out in the front of it. And that's because I want it to integrate to 1. And so I want to go through the argument for why the normalization factor should be 1 over the square root of 2 pi. So that's what we'll cover in topic 7. And then in topic 8, I want to work through calculating something called the marginal density of a bivariate normal distribution. And so this is actually just a single partial integration exercise, but it's a very complicated integral to look at. But again, there are some tricks that make it easier to evaluate, and so I want to go through those once in class just so you have the opportunity to see them.